This is IBM Museum, and behind me I have my IBM PS2 Model 30. Time to get back on track with the IBM systems. I refer to this system as my Maxed Model 30. It is one of the originals that was based on the 8086 CPU at 8 megahertz. I've gone through and I have replaced that with an NEC V30 chip that's also 8 megahertz. It's got a numeric coprocessor. I've gone through for the 720 KB diskette drive that it originally came with. I've got that swapped out for a 1.44 megabyte drive. It goes through and reads those and writes the disk perfectly fine. I actually use this system to go through and create reference and star diskettes, I think, in a video. This is a little bit of demonstration of the system again. I think it's appeared on video before. It does have the external 4869 360 KB drive, and I've got that adapter inside there. There is a SCSI adapter, a Trantor T130B SCSI adapter that's 8-bit, has a ROM BIOS on that to go through and be able to boot from a 1 gigabyte hard drive that's internal behind that drive bezel. And then it also runs the external CD-ROM, SCSI CD-ROM that I have there. And so it's got all those powerful drive components upgraded. And then I've got a VGA adapter on there as well. And this system, actually, I've got Windows 3.0 on it. And I'll go through and I'll show how fast that loads and everything else we can see on video. And then my intentions for this video, and I don't intend it to be very long like the last two previous videos. I'm going to go through and I'm actually going to use one of the UNPC utilities, that I/O port reader, in real time to kind of show what I've used that for in the past, to kind of look at the functions on the system. And the Model 30, it does have a different real-time clock chip in it than the other PS2s. And the interesting thing is it rolled over, that clock chip on it rolls over through that Y2K stuff just fine. Transitioning from the year 1999 to the year 2000, didn't have issue 1 with that. So we'll see a little bit of that as I go through and kind of show the date and the clock features, and that's what I'm looking at in those I/O ports. But let me flip around, get the system on, and I'll try and quickly bring up the video for that, of the video capture showing the system boot. We can kind of time things and see what shows on the screen as the system boots. Okay, and I'll go through and so it's doing the RAM count, and again it just has that 640 KB of RAM. That's in 2 SIMs, and then 128 KB of RAM that's soldered onto the planar. And it's going to go through, and probably the video capture, I'm trying to get the full screen again, so that you'll see that shifts a little bit more. So there it is, fully completed. You can see that it's loaded those drivers for the CD-ROM, so that would be accessible. I could even put a data disk in there of CD-ROM, and it would be able to read the contents for that fine. And let's go through. I don't have it starting Windows automatically. What I'm going to do is I'm going to type in to start Windows. And you can go through and kind of the time frame to show okay, hourglass went away. So we are able to go through version 3 from the copyright date of way back when. Free memory, 324K of free memory. And this is running in real mode. And I could go through. I don't have anything loaded on this machine other than just the MS-DOS regular utilities, and the accessories are all the standard things. I guess I already showed that applications. Where's my accessories? Games, accessories. If I'd actually read. Okay. Just the standard things. Let's look a little bit at the clock. And that's tracking good for the time that it is right now. Close that. Let's look at the calendar. We'll look at this under DOS as well. Nothing scheduled on my calendar for Friday, January the 15th of 2021, even making this video. And of course, it also marks the time on that screen. Okay. And then in the main group, we have our file manager. You have to remember how it's going to show. And here it's got to go through and identify a little bit more of the drives. So that's probably going to take a little bit of time. There's our C drive. We could go through and even read the CD-ROM, which is identified correctly, the external 360 KB drive, or the 1.44. And I don't have disk in the removable drives at all. Maybe that's a good, that'd have been a good thing to demonstrate as well. But we're going to go through, we'll exit Windows and get on to the planned topic of this discussion. And so, again, the date and time, and of course, looking over some of these numbers for this, because that's going to come up for the UNPC. I'll change over to that directory. I have it on the system. And for the IReportViewer, it's just that UNPC program and selecting it from the menued program, the menu there, IReportViewer. And for this, I don't know. In fact, I should have gone through the video prepped for it earlier and looked at that system information. Sometimes when it goes through, and I've seen there's a bug, and I think I corrected it back when, if it finds a particular, it can't handle some of the CPUs, it seems, or I was having that CPU portion crash of the UNPC. So this is viewing the ports and the information I want to look for, and it's too bad that, I mean, I have the mouse here and able to run that around. I thought at one point that this had mouse support, and the UNPC, but I guess not. It's just a full screen program with keyboard support. But I'm looking down at the second to last row there, the 00E0 row. And we see some numbers kind of churning over there. If we look a little bit to the, kind of towards the middle, remember that the system was at 7 o'clock, which is 1900 military time. So 19, that column of 7, because it goes through the bytes across the those columns from, and this is the real-time clock of the MUL 30. It's set at this particular address, and that's unique for this system. That's just the way it was designed, and it has that clock driver built into the BIOS as well. It's really nice in that regard. It's the same clock chip that came on those AST clock boards, like the 6-pack and things like that. You had the little coin cell battery, and sometimes even bigger than the CR2032s. But you had to have the driver of astclock.com to go through there. And even some of that had bugs for the Y2K and other aspects that you had to go through and correct, or had the latest driver for those. But it's the same clock chip, but that's the, and normally it's a national semiconductor or equivalent of the MM. I'm trying to think, it was like, it's like 58167 AN, I think. And that's in that, that MUL 30 schematic that's known about out there as well. Marks that chip and how the lines are set up. And the thought is, if it goes to the point of putting a real-time clock chip on the MUL 25 and using the MUL 30 BIOS, of going through, and if you have the real-time clock at that address, it's going to function fine. And I went through and I wanted to know back years ago, and I figured it out through this method of what these different fields were. As I said, the 19 that's on that last row in column 7 is the hour. And right next to it, to the left, is 52. So that's 752. And then you can see the next number to the left changing over every second. So that's tracking your seconds: 45, 46, 47, 48, 49. We'll see that go up to 00, and of course the minutes will increment from there. And the two fields that are to the left of the seconds, those are even microseconds. Those are going through. That's why they're toggling through so fast. And then we see those preceded by that FFFF in the 3 positions. And I'm not sure if that field is just unused. That may be a timer section. The MUL 30 had a timer functionality, just like the PC convertible, to be able to suspend or turn, like the convertible, it could actually suspend or turn off, turn on at certain times. And of course the MUL 30 has that hard power switch, so it's but there is some timer functionality that's shared with the PC convertible. Now in that, to the right of that, where it has the clock values, then we go to that 03, and I looked through and I didn't see this for changes in the date. I didn't see that change, and so I have to determine, maybe that's just flags in there or something else to the clock, or whether it's showing in like a 12-hour mode or 24-hour mode or something else. I'll have to look that over in a little bit more detail. And then to the right of that, we have 15 or 15. That is the day of the month. It's the 15th. And then to the right of that, the 01 being January, the first month of the year. To the right of that, we have C0. And this is some sort of century indication, but I haven't figured it out for the what we're in right now. In the 2000s, it's C0. When the clock chip is set to a date in the 1900s, it is F0. And those are hexadecimal values, of course. But they somehow that coordinates. And as long as I know those two values, I mean, I don't have to be concerned with anything more than 2 centuries. I could go through and try and set the clock to 21, something, or and see how that value changes. But I'm generally unconcerned as long as I have those two values pinned down. Really, for all the rest, I don't think the small 30 is going to be operating in the year 2100. And I think even DOS dates and stuff like that, they start failing at certain point too. And then to the right of that, we do have that 21 showing the year that we're in. And then the last 3 areas of those registers for the real-time clock, because it goes from 00E0 up to 00EF is the last register. That, again, still may be some sort of the timer functionality or something else, but those don't have any values in there. And the clock chip does have those registers for some reason, but they also might be unused. So this is going through and kind of showing how a utility like this I/O port reader, and I could even go through from debug or something else, and I could plug values into those areas if I wanted to change the year or something like that, instead of just the using the time and date command. I could go through and have my utilities that read that time and date, or go through and write a particular date in there as well. But that is a functional use of this utility. So, I mean, going through some of the ports that are used on other systems are not necessarily as active here, or there's there's not as much going on. And clearly those other systems, some system goes through and as system control for that particular row, but in this case on the MAL 30, that's for the real-time clock use. And then above that, in the row of the RTC and CMOS registers, normally being at port 70 and 71 hex in a 286 system or above, and that's at CMOS ROM contents that we talked about. And that's just through the 2 ports of 70 and 71, generally writing a value to port 70 of which register you want to read, and then reading port 71 back to display the contents for changing that register, writing to port 70 of the particular offset of the register that you want to write to, and then with port 71 writing the value that you want to send to that particular offset. So just a little bit different functionality. Of course, the author of the book is going through, or the creator of the program is going through and just marking those comment areas or those notes as what most of the systems, at a mid-level use that stuff for. So, if definitely a shorter video, if you like the content that I presented here, we're back on an IBM system. I've got a few ideas for what I'm going to go through and do. I even thought about the Tranter SCSI controller that I have on the small 30, of going through and trying that on a PS2 model L40SX. That's a laptop based on the 386 SX CPU. And just to kind of see, because I got a device called the communications cartridge that hosts particular 8-bit adapters off that system, and we might see if we can also attach this external SCSI CD-ROM to that L40SX and get it reading CD-ROMs as well, or me being able to move that drive around. But that is all I have for now. If you like this video, click on that like button. Please subscribe to my channel if you haven't already. That is all I have for now. This is IBM Museum. Thank you.